Hey guys, Brian here. Welcome back to outside the shop, but it's going to be going in the shop, so it'll be okay. Got one of the coolest things that I've ever owned here behind me. Let's take a look at this piece of World War II vintage machinery and talk a little bit about it. So, what I have here is a Dynamometer console, and it goes with this dynamometer here. For those of you that don't know what a dynamometer is, it's a device used for loading and measuring horsepower. This being a water brake style dynamometer, so it uses water as the loading mechanism. However, it can also use air on this particular one as the loading mechanism. This thing is World War II vintage and a very high torque unit, but still higher horsepower. So I don't believe it was used in diesels. I'm pretty sure this came from the Hall Scott factory and was used on the Defender engines, which were used in marine amphibious boats during World War II. And this was probably a, well, I wouldn't say it's a break-in dynamometer, because this is a little higher class dyno than a lot of them. This is the instrumentation is fairly technical, and it's a little bit fancier dyno than what you typically see. So this is more of like a laboratory kind of research grade type dyno. Wish I knew the history on it, but I don't. Got another little water brake that came in the package deal. It's just a super simplistic water brake. So it'll be fun to try and get a drive shaft and hook it up to a tractor or something and see if we can get some reasonable measurements out of it. It just works off of a brake master cylinder, and then it should have a pressure gauge to read the force output as the brake is applied. So there's the data tag. So it's rated at 500 horsepower from 1310 to 4000 RPM with a water pressure of 45 to 50 pounds. So basically this is a 2,000 foot-pound torque dyno, and because of the way it's configured, got the boss coming to check. Because of the way it's configured, it uses a closed system. This is the water pump, and it pumps a fixed amount of water into the brake to apply the load, and then the water is trapped in the brake. It doesn't ever leave the brake. It's a closed loop. Most modern dynamometers, water brake style, run the water through them for cooling, because it's easier to do that way, and it's kind of a lazy way to do it. This is a more accurate method to apply a constant load. This is not really for a sweep type dyno. This is for a steady state load dyno. So at steady state, it can absorb 500 horsepower through those twin coolers underneath of it. If it had more coolers, it could absorb significantly more horsepower, but that's all the coolers are good for, so that's why it's rated at 500 horsepower. Across that RPM range, that's all the heat it can get rid of. So for a short period of time, it could go substantially higher, but for continuous steady state use, that's the limit. So from what I figured out, that's how this works. I got the water pump here, pumps water into the brake. The brake centrifugal force pumps into the inside, and it slings out, runs through the coolers and circulates. This is an air apparatus. You hook this up to air pressure, and you can apply air pressure to stabilize the load. Sometimes with a very small amount of water in the brake, you get kind of a hunting, surging, and by using this air in the system, you can take that out of it, and you can apply a load a lot more sensitively than you can with just strictly the water. So this is an air over water combination dynamometer, so that you can get a nice steady state smooth pull. So this thing's been sitting outside forever. Who knows when it was last used. It does still turn. So, but I'll have to take it all down and check over all the bearings and seals and do a total rebuild on this thing basically. But before it's ready to do any actual dynamometer applications. It's free still. This is a load cell. So I've got an electric strain gauge deal for measuring the torque that's applied. Got a fancy little pivot set up to try and minimize, uses this triangle point to try and minimize the rotational friction, so you're not losing in your horsepower measurements or your torque measurements. It's really you're measuring the torque, because that's what dynamometers do. They apply torque. Then you got a RPM generator here. This Weston tachometer magneto here makes a pulse to drive the tacks coming off the end of the dynamometer shaft. It reads the direct RPM, so between the RPM and the measured torque you can calculate the horsepower. You can see the coolers underneath there with the date of 4/28/45. So these are right at the end of World War II. And it's their BTU capacity that limits this unit to the 500 horsepower. So there's various valves and tweaks you can do to make this thing stabilize and run like you want it to, so that you can load virtually any engine that can produce less than, or that produces 2,000 foot-pounds or less of torque. It's got a broken fitting there. These are part of the heat exchanger system / attenuators. Got a valve there that opens and closes so it can pump water into the brake or let water out of the brake, depending on whether you need to increase the load or decrease the load. I can't really say it's something I know a whole lot about, but I haven't figured it out. It's not terribly complicated. Since air pressure regulator. And that's where your engine hooks up. It's not seized. It's got hope. It's a nice heavy built unit, but it's going to absorb 2,000 foot-pounds all day long. It probably needs to be. Over here is the actual console, where we've got multiple RPM gauges. You can see they actually go to 5,000 RPM. So this is the safety governor, so apparently they must have planned to be able to run this to 5 grand. This applies the load increase or decrease to the dynamometer when you turn the switch. Got an engine start button, main power switch. Oil heater. Don't know what that light was. Or that light. Some kind of a mercury switch. Apparently oil pressure cutout, probably killed the ignition, I'm gonna guess. You got a magnetic scintilla ignition control down here. It says Navy. So apparently they were running some gas engines for the Navy on here. It's going to be my guess. Who knows what they would have been. And we've got the regular data station over here. So there's about 90 degrees outside here right now, so that's accurate. We got these engine temp and probably manifold pressure, manifold vacuum. I got a regular, says manifold pressure there, but that's reading ambient air pressure right now, just over 30 inches. We got a pyrometer, which can be switched to one of 6 cylinders. So they're apparently running either a big 6-cylinder engine on here or just had one every other cylinder, perhaps. I don't really know. And we got some override switches and that one says engine something. And that one I believe says compressor or something. Maybe those are engine temp and compressor temp. Had overheat switches on them. It's hard to say. I know what all these gauges were. These are all, I believe, pressure gauges, these 4 over here, for whatever you want to read pressures on, probably fuel pressure. And I think that this one here that I can't read anything on is the load cell meter. I believe that gauge there is what would have read the strain gauge values coming back for your torque measurements. It will give you a value there calibrated to whatever voltage it was inducing. And then it's got various resistance pots that you can use to zero it out or calibrate it or whatever. Would like to know more about this. If anybody's familiar with that at all, that'd be great. Let me know, 'cause I can't find any info on it. You can kind of see it there on the back side of that panel. There's a switch there at the bottom, some various resistors that can be tweaked in and out up here on this left side, looks like to me. And you got your main gauge there in the middle and just your selector switches over there for different taps. This is all of the dynamometer hookups, which of course I have no instructions for, so I have no idea what they're all wired to. The wiring on this is somewhat sketchy, but it's really not horrible either. Definitely that World War II vintage cloth covered electric wire. Most of the wire has to do with that ignition circuit in the middle, which I wouldn't be using. Boss is unenthused. So here's the data tag on that. And obviously that's designed to have some tubes installed in it there. And I believe that's some kind of electronic feedback governor system. Got a couple of lines coming up there to hook to something. Not really sure what they would have gone into here. This maybe. Oh yeah, I guess they were plumbed into this oil pressure switch, perhaps. I don't know. Let's see here what would have gone to that. Yeah, this is going to be the oil pressure one. Maybe there was another meter up here somewhere. So there it is. That's the serial number. Fairly early in production. From what I understand, what I was told when I bought this machine is that it was the second one that Clayton had built. I don't know if that's legit or not, but of this style machine anyway. Supposedly one of them went to Greyhound bus and this one went to Hall Scott. But that's all your selector switches for your readouts over here. Engine RPM, low or high. For these are dual charted tachometers. Like that one there, you can see it goes to 5 grand or 2,500, depending on what's on low or high. And then you got a horsepower readout, low or high. Dyno temp warning light, a test switch. I have no idea what it tested. Dyno cooling water inlet pressure reader. And Dyno cooling water temperature reader. So, keep an eye on those. You want to try and keep it fairly steady if you're doing laboratory type readings. You don't want a lot of variance in your temperature because it can change what the horsepower reads out since you're measuring the torque. Steady state. You don't want the engine hunting around either. So, I'm not sure why there's a horsepower reading here. If it's got dyno RPM, almost acts like it would be a horsepower direct readout, but so without knowing the RPM, it'd be difficult to have a horsepower readout. I wonder if it had a circuit to do that. If instead of saying 5,000 RPM, if it goes to 500 horsepower. It's a 273 gauge. A Weston. Wonder if there's anybody around still. This company, if I gave them that serial number, if they could tell me more about it. Looks like 35482 is the serial number on this gauge. I'm sure at one point in time you could find out everything that was ever to be known about that, but I imagine it's a lot harder to do today. Most all these companies, sadly, gone out of business. This Weston outfit's really interesting history on them. They were one of the first to build some very high quality instrumentation gauges. These were top of the line gauges back at the time. And for many years, for probably at least 50 years, this was the best gauges you could buy were Westons. This brown electric pyrometer is the same one that's on my heat treat oven. So I'm kind of familiar with them, how they read out. Again, we're reading 90 degrees over there today. I'd say it's probably accurate. Actually, it only goes to 600, so that's a fairly low EGT gauge. But could have been they were reading actual cylinder temperatures, perhaps, maybe. I don't know how hot an aircraft cylinder temp reads on an air-cooled engine. Maybe 300. It's certainly a cool looking piece of history. Getting it going will be quite the challenge, but I think it'll be worth it in the end. can see the hookups on the back there for the tachometers and the switching controls. And the taps for the horsepower meter. I have the RPM signal going into it off of this one into that one. They share an RPM signal. I don't know if the RPM signal combined with the output from the strain gauge would give you a direct horsepower rating or not. I kind of feel like that it wouldn't, but maybe they had a way figured out to do it. Have to trace down the wires and see if I can figure out where they go and how they had it hooked up. And again, could have to do with that there. Bailey's not talking. He's not telling me how it's done. Oh man, somebody spent a lot of time sitting here at this console testing engines at some point in time. Logbook out here and writing down all the notes, monitoring everything. Hope to be able to use this in some diesel engine development of my own. I'm not terribly worried about the limitation of the 5,000 RPM max. This gauge here went to 5.2 originally. I'll go get this thing put inside till I'm ready to tear into redoing it. I hope you enjoyed that little introduction to the ancient Clayton Dynamometer from World War II. And if anybody's familiar with any of this or knows anything about it, or knows anybody that would know anything about any of it, and can get them in touch with me to help me figure this thing out, I would greatly appreciate it. But for now, it's going up inside the Quonset hut and storage until I get ready to tackle going through the wiring on it and tearing this dynamometer apart and seeing what bearings and seals and stuff I'm going to have to go through it to get it rebuilt. And then I'll have to work on getting it plumbed up and getting a proper size pump and all that stuff. I'll probably tee it into my water in the floor system. That way, in the wintertime, you can run engines and take the heat and heat the building with it. There's no need in wasting it. Plus, at the same time, it's a good cooling medium for the dynamometer, even in the summertime. The floor can absorb an immense amount of heat because of all the mass of concrete. So it makes it like a giant radiator. I can run a closed loop system, not have to flow water through this thing, and just run the water system I already have, circulate it through there and keep everything in check and have a good, usable, high class, fine, sensitive dynamometer that operates in the kind of range most of the engines that I fool with operate in. So, hope you enjoyed. Thanks for watching, thanks for subscribing, and I'll catch y'all later.